focus on the ones that do not come in parallel or perpendicular to normal planes, because we need to describe those. All right, let's go to page 654, 655. And let's talk about how we build auxiliary views. There's two ways you're going to do it. They are both shown on page 655. Alrighty, so when we're looking at this page, the two ways they show you, one is what we call the fold line method of constructing these views. You're seeing it right here. Remember, a fold line, like this phantom line that's shown here, we usually use phantoms for this just to display it. Those lines, by the way, will not be on your finished drawing. We use them for construction and then turn them off and delete them. But the fold lines represent where the glass box opens, and you can kind of see them right in here, same deal. Now, what we know about these when this object's sitting in this glass box is that it can't move in the glass box, therefore related views have the same dimensions and they have to be equal from fold lines through. So in essence what they're saying here, if I do a fold line on my auxiliary view, since this is a depth dimension, it is related to my right side and my top view, and the distance from this fold line to any feature of my auxiliary has to be equal to the distance from equal to the distance from this fold line to any point in this feature. That's what in essence this is saying. Remember that on this auxiliary, since it's pulling a depth auxiliary, the depth dimension is the only true dimension on there. You might want to think that there's two and it's been rotated, but in essence, that's depth. The other two dimensions are kind of skewed in there. So you want to be a little careful about how you're dealing with those. So that's the fold line method. We're transferring the depth dimension from a related view. We're still doing law of one, which is project perpendicular to the fold lines. Also, because we need two projections to locate a point. So in essence, that's the fold line method. We'll go and practice that in just a moment. The other way we're going to deal with is what we call the reference line method. Now the reference line method is just a shortcut to do the exact same thing. In essence, what we do is we pick a plane on the object that is controlled by the depth dimension, and then we use that to transfer all of the dimensions. Now it can be an existing plane or it can be an imaginary plane. Whatever, it doesn't matter. So let me just kind of demonstrate this. Here you have a 3-view drawing on the reference plane. This little one they've got shown right here is going to be your reference plane. Now, you'll see this red line in the right side view, right here, and you see that same red line in the top view? That is this plane, or your reference plane, as an edge. You're seeing it as an edge there. So, in essence, think of it, that reference plane, we're just picking a plane, and we're going to see it on edge in this view, we're going to see it on edge in this view, so therefore in my auxiliary I have to see it on edge here. Now, I picked it here so that I can say, well, I know it's here, but depth goes this way, depth goes this way. Can't I just measure from that plane to there, and then it will have to be the same in all views? And then, yeah. That's in essence what we're doing. We just picked an existing plane on an object and use it like a fold line, because it's still giving us a depth reference. We can also take this plane, and since we're just picking one, we can make an imaginary one, like in this instance. They put one right through the middle. So again, I'm seeing it on edge, on edge. Now, for me to build my auxiliary then, I can then just take this line, set it over here, and offset both ways, and I get all those dimensions at the same time for one measurement. So we're just picking a plane that is useful to us. And in fact, when you do circular features, that's pretty much what you're going to do every time. It is that center reference plane. So two ways. You got the fold line method, and you have the reference plane method. Both of them in essence work the same, we're just using a different datum to transfer the measurements.
Can I ask you,
Yes.
so when you're doing your reference plane, so you measure from your view up the same distance from each side?
No.
I mean, do you have to, is there some,
No, the only thing we're worried about on the reference plane is the distance from the reference plane on one of these views to any feature on here. That's all we need. The distance from in between here, the front and the top, and the front and the right.
doesn't matter?
Is irrelevant. It
Okay.
doesn't matter a bit. We can have them wherever we want.
You only get depth, not getting the other uses.
That is
Got it.
correct.
Okay.
Okay, so in essence, if you forget this, the author has some pretty good examples, like when he's showing how on 657 how to do a depth auxiliary, what the author walks you right through it on 658. For the height auxiliary, he walks you through it on 660, and the width also on 660. And these use the reference plane method as the author goes through them. Okay? So let's practice the reference plane method. Let's make sure, or not the reference plane, excuse me, the fold line method. Okay? So we're going to go to the computer, if you would, on that file I threw out there. Juan, can I get you to hit this front light, please? Okay, the first thing we have to do when we get into these is go ahead and place and get the drawing set up. So here we have a 3-view drawing. I wouldn't label the vertices so you can try and get an idea of this. It's basically a prism with the nose cut off of it. And you see it right here. That creates an inclined plane. So there's a couple steps that you want to do with auxiliary. First, understand the plane you are trying to display. And we'll make that quite apparent over the next couple days. That's the first step. You got to know, am I going an incline? Am I going an oblique? Am I doing a dihedral? Because they'll have different steps for each one. In this case, we are doing an inclined plane. So if you want to relate this back to the laws of descriptive geometry, you would look at the law 3, which states that a plane appears true size and shape in the viewing plane parallel to its edge view. Okay. Now that's a law. With an inclined plane, don't we see foreshorten, and edge?
Yeah.
Okay. So in essence, we've already got an edge. You're at law 3, because you've got an edge view. So therefore, we can find true size and shape with one rotation. Now, what we're going to do here is we're going to put some planes out here. So I'm going to come in on this object, and I have to get the distance from here and here to my reference, or I keep saying that, my fold line exactly the same. Okay. So we'll just do an offset of like 2 or 1. We'll do 2. Okay. So we're just going to do that, and we're going to create a plane right here that we can then measure from. Okay. So that's going to be the first step. Since we're at an inclined plane, we've got one rotation to see it true size and shape. So I'm just going to come in here and do an offset at 2, and I'm going to throw that line out and that line out. Now, I'll change the color on these just so you can see them. So I'll go to the 0 layer. And I kind of also like these to be phantoms. So I've got those 2 reference planes set up. Again, like Lisa just asked a minute ago, the distance from my front view to here is irrelevant. I don't care. Don't care. That is, I gotta care about this one. Okay, the distance from my fold line to my object must be identical to this one to this one. Okay, now I don't need both of these views, but we're just setting it up on both. I can really build this off of either nothing but the top or nothing but the right. Now, once we do that, we now have to create that identical fold line for our auxiliary view. You've got the edge view sitting right here. Okay, so we now know the angle, because we want to come in perpendicular to this, right? So let's do an offset in this case. I think 4 works pretty well for this one right here. And I'm going to put it right there. So just offset that one and do a 3 or a 4 offset. So you should have 3 lines on your drawing now. Does anybody need a little more time? Okay. All right, this fold line, and this fold line, and this fold line, they're all the same, right? Okay, the distance from here out is depth, here depth, here depth. Now, we're going to use the orthographic projection law of 1, which states that I can project perpendicular to any view into any adjacent view. This auxiliary view is adjacent to my front, correct? Okay. Yeah, it is. Sits right next to it. It does have the other dimensions in there, even though they're not true. All right, so the first thing I want to do then is I want to create some projection lines. And I basically, the way I do these, I just get out way far, click a line, use my perpendicular snap to that plane. So that line's perpendicular, and then I'm just going to move that to the point in question and copy it to any other points I might need. So in this case, we really only have 2. Now you want to make sure, folks, when this comes in, this line must be perpendicular to the plane you are looking for. Any of you good at shadow animals?
No, you good?
David, I figured you'd be good at it.
You got very well.
Is that a butterfly?
Sure. Birdie as well.
What? Yes.
Let's do a line, click out there somewhere, use your perpendicular snap,
Okay, very good.
make sure it's perpendicular.
Can I ask how did you fan line that color? If I go to fan, it's blue, and if I go change it to white, it goes to solid. How did you?
I did.
I just use properties.
And that's
Well,
the
you
same,
match
I mean, we have the
properties,
same
and
one.
then I made my fan, and then I went to make it white.
That doesn't mean.
Straight line instead of fan.
At least you're not perpendicular, use your perpendicular snap. Delete those, it just line,
But that won't always work like that, you know what I mean?
yeah, shift right.
Hey.
Got it? Okay, click it. Just go perpendicular. I think it on the corner. I don't think it did. Force it, force it. Shift right. Shift right. You're not using it. Remember that override deal? So we're gonna do a line, we're gonna click out here, we're gonna do shift right click, and we're gonna tell it you can only use perpendicular. We're gonna click that perpendicular. Okay? Like this, move these with. Do not have an endpoint standpoint. And then just copy that to the other line. Well, didn't know perpendicular lines were
See?
kind of a struggle. Is it Monday?
Yeah.
No, it's Friday. It's the same problem.
Yes, Missy, I'll come in. Yeah, good, it should be, so just move
Oh,
it.
it should.
No, just move it. Just do a move. Move on that line. Okay. Now just move that one. Do that. Yeah. Now just use endpoint to endpoint. You can use grips, just grab your grip right there. Click on that grip, now you use your space bar to go in the loop command. Use your endpoints.
Okay.
Juan, you good back there? Okay. Missy, you ready?
Yes. Good.
Does anybody need more time? All right. Now, the thing to know here, right, this is law 1 of orthographic projection. So we know points 1, 2, 3, 4 have to fall on these lines. What we don't know is where they fall on them. You're going to get that from your related view. Right, same thing we've done all the way along. We've taken two views to construct another one. So I can come to either one of these views and I can do the offset distance from my fold line to this edge, or points 1 and 3. That will give me that distance, and it's going to pop up somewhere about right here. Then I can go from my fold line to points 3 and 4, set that distance up, I'll get another line across here. That's going to outline this shape, true size and shape. Okay. Now again, you may want to give yourself some lines so that you do not get off. Okay. Because folks, if I come in here and I do offset from here, and maybe I get the midpoint snap, or I've got my nearest snap up, which some of you are running with, which I would tell you right now, get that thing off of your O snaps. And I know some of you have that running on your O snaps. You don't ever want nearest on there. Okay. But that is not the true line distance, right? I need the distance straight. So I would almost, if you have a struggle with this, come out here and draw yourself some lines so that you can snap to them and get that distance perfectly. Okay. So I'm going to do an offset from my fold line to point 1. And I'm just digitizing in my offset distance, and then I'm going to offset my fold line in my auxiliary view. Okay. So now I've got this distance right here. Let me switch that, guys, so you can see which line it is. Okay. So what I did was I came in, I used the offset command to digitize from my fold line to point 1. And then I offset that distance right here. So that is the same as that. Okay, so go ahead and do that offset. I'll do it one more time if you are a little confused on what I'm doing here. So I hit O enter for offset. I get on my fold line and I just click there and there. AutoCAD read that distance, right, and put it in my offset command. Then all I do is come up here and offset that out, and I'm done. That distance is 2, by the way. If you know it, you can just type it. What you just did was you located, there's point 1, and I think that's a, is that a 2? I can't see that.
Yeah.
That's a 2? Okay. So we just found points 1 and 2. Now, we now need to find points 3 and 4. So I'm just going to do the offset again. This time from my right side view, I'm going to come from point 4 to my fold line. That puts the distance in the offset command. Then I go to my auxiliary and I offset my fold line again out. Okay. That gives me this line. Okay.
Where'd you get that one again?
Okay. One sec. So this is this a 4, the top one?
Yes.
Yes.
Okay, so there's point 4, there's point 3. So the distance from here to here was points 1 and 2, right there. The distance from here to here is points 3 and 4. Okay. So those are all equal. There's 1 and 2. And then I'll do it up here. Here is 3 and 4. Boy, great arrows, Pat. Okay. Do you see where those are coming from? All right. Now, when we do auxiliaries, like we talked about yesterday, we're in essence really going to just invoke the partial convention, because everything else is described by my orthographic views. And so at this point, I'm just going to come in and clean this drawing up. We'll trim off that, get rid of these two, get rid of all this. Okay. That is the true size and shape of my inclined plane. If you're wondering if you got it right, you can use the distance command if you wish. I will, let me throw the size of this thing up here. So you should have the same size as me. 2.12 for the width, 3 is the depth.
Do you not, do the other, because that's a top view.
No, it's not. It's an auxiliary view. It's a primary depth auxiliary view.
So it's only that point.
It's only that plane. That's it. That's all we needed. The glass box, our standard 6 views, did a very nice job on the rest of it. All right, are we good? Good, we're going to do it again. And we're going to do a different method this time. Now, folks, I'll tell you straight up, you need to know both of these methods, the fold line method and the reference plane method. Now, we just did the fold line. You're going to know why we do the fold line when we come to Monday, because we're going to go to obliques and dihedrals, and you'll know why we need fold lines at that point. But we can also use a reference plane. Okay? So we're going to use a reference plane this time to do this thing. And to get it set up again, if you would, just go ahead and delete everything that we did out of it so you're back to the original. Now with the reference plane, remember what we do here, what we just looked at in those figures. You pick a plane on the object that you see as an edge to transfer depth dimensions. So if we look at these views here, what I'm looking at, since I know I'm doing a depth, I'm going to go to a view that has depth in it, like this one or this one, either one, it doesn't matter. And what I'm going to do is to say, you know what, I see edge view here, okay? So I can use that plane to transfer my measurements, since I'm seeing this as an edge. That's fine. So all we're going to do here is offset for a plane where I'm going to take this plane, transfer it out to right here. Now it's really a fairly simple process. Usually the reference plane will reduce steps you need to do. So here I'm just going to do an offset of 6. I'm just going to throw that thing out. So I just did an offset, and I offset the edge view of my inclined plane out, and I just went 6. You all there? All right, folks, here's what we did. Here's my reference plane. I'm seeing it as an edge, right? That's that same plane right here I see as an edge. Well, I'm also saying that's it right there now, too. Okay, that's it. And it is, because it is points 3, 4 that are right there. So now I use the reference plane, and don't lose sight of where it is. I'm, again, just going to use the offset command. I already know where points 3, 4 are. They're right here. Now I'm going to do an offset, and I'm going to come from my reference plane to any other feature on the object, right there. And then I'm going to offset that back in. So I took my reference plane, measured the distance. I used the offset command to measure the distance to the next feature, which in this case is this edge, and I offset that back in. Always go the same direction.
You get me back.
Sure. So there it is. That's the same as 3, 4 right up here. So I'm going to do offset, and I'm just going to measure from there to there and throw that distance out. Now on this one, once you do that, once we already know our endpoints, so I could just draw those right in. But just to show you that it works, I'll again get out here, you force my perpendicular snap. Okay. So there it is. Then move this guy to an edge and copy it to the other. They should all match up. Trim this guy up. There it is. That should be the exact same shape we just created. Where here is point 1, 2, I think that's 4, I can't tell on that overhead. There's 1, 2, 3, 4. So the reference plane method, quick and easy, right? No fold lines. We really only had one offset. We picked a plane on the object to transfer our depth dimension. You have to have edge view in these views to use a feature. Pretty straightforward? Okay, good. Those are your two methods. Now, if we can work from an existing multi-view to an auxiliary view, when I get an auxiliary view, can I work backwards into my multi-views? Sure, why not? Just turn the process around, right? We call this reverse construction. Now, the reason we do this is because many times these auxiliary planes have features on them that are much easier to draw right here than they are somewhere else. Case in point, let's look at a figure in your text. Let's go to figure 1314 on page 665.